Have you ever looked at a child's toy, a spinning top, a slingshot, a model rocket, and thought, could this change the world? Welcome back to Everyday Inventions, where behind every object is a hidden story, sometimes silly, sometimes spectacular. Today, we explore a curious question: what happens when play turns into purpose? Because believe it or not, some of the greatest tools of modern life didn't begin in research labs. They didn't come from big budgets or military contracts. They began in backyards, on bedroom floors, in classrooms, garages, and treehouses. They started as toys. Not blueprints, not government grants, just wonder, imagination, and a little chaos. This is the story of how play gave us more than just joy, it gave us innovation. From plastic blocks that inspired robotics, to remote control toys that led to drones. We'll see how curiosity, unstructured time, and childlike minds quietly transformed the future. So buckle up and maybe grab your favorite old toy, because today's journey is powered by fun. Segment 1. The Slinky, Born to Fall? In 1943, aboard a naval engineering lab in Philadelphia, Richard James was trying to solve a serious problem: stabilizing delicate ship instruments on rough seas. He tested springs for shock absorption, stiff ones, soft ones, coils of every size. And then, by pure accident, one of those springs tumbled off his desk and walked. It didn't bounce. It didn't roll. It walked, step by step, like it had a mind of its own. Richard froze. But it was his wife, Betty James, who truly saw the magic. She didn't see failed equipment. She saw a toy, a character, a Slinky. Together, they named it, packaged it, and introduced it to the world. Within months, store shelves were empty. Within years, hundreds of millions were sold. But the story doesn't stop in the playroom. That same helical design, so mesmerizing on stairs, turned out to have real-world utility. The Slinky's metal coils became portable antennas for soldiers in the Vietnam War, allowing quick deployment in the field. In classrooms, physics teachers used it to explain wave motion and energy transfer. And in space, NASA included Slinkies in zero-gravity experiments, where they floated and danced like metallic snakes, revealing the mechanics of motion without gravity. What began as an engineering mishap became a scientific teaching tool, a military solution, and a space-age experiment, all from a spring doing somersaults. Sometimes, the bridge between seriousness and silliness is thinner than we think. Segment 2. The Gyroscope, a Spinning Secret. Simple, ancient joys, carved from wood, bone, or stone. They've been found in the ruins of ancient Egypt, Greece, and China. Children spun them for fun, watched them wobble, and raced them across dusty floors. But then, something changed. Centuries later, inventors and scientists looked at these spinning toys and didn't just see play. They saw potential. What if that spin could do more than entertain? In the 1800s, French physicist Léon Foucault built a strange device, a spinning wheel suspended in gimbals, to demonstrate something profound: the Earth's rotation. This wasn't just a top anymore. It was a gyroscope. It didn't wobble like a toy. It resisted movement. It held its direction. And suddenly, engineers had a powerful new tool. Today, gyroscopes are in everything. They help planes stay upright in the sky, giving pilots balance and direction in clouds. They guide submarines deep below the ocean's surface, where no GPS can reach. They're inside your smartphone, allowing it to rotate maps and keep your screen stable. And in space? Satellites and probes rely on gyroscopes to hold orientation across millions of miles. From ancient courtyards to orbiting spacecraft, this invention has come a long way. All because someone looked at a wobbling top and asked, what if we spin this faster? Smarter? Forever? Sometimes, the line between toy and tool is just a little momentum away. Segment 3. Silly Putty, the Accidental Chemist's Pet. During World War II, the US faced a serious problem. Rubber was running out. With supply routes cut and military demands soaring, tires, boots, and seals were suddenly precious commodities. So, the government turned to scientists. Make rubber without rubber. Labs across the country scrambled. Chemists tried every compound they could find. And one day, inside a General Electric lab, a scientist combined silicone oil and boric acid. The result? A strange, gooey substance that stretched like taffy, bounced like a ball, and snapped like brittle glass. It wasn't durable. It couldn't handle heat. It was completely useless for military tires. But someone saw something else. The toy. The odd substance found a home inside plastic eggs and was rebranded as Silly Putty, a goofy, stretchy companion that could copy newspaper ink, bounce in weird directions, and amuse kids and adults for hours. But Silly Putty didn't stop there. Over the decades, people found real uses for this glorified goop. The office workers used it to pick lint from clothes and clean crumbs from keyboards. The engineers discovered it helped dampen vibrations in delicate tools. Therapists recommended it for relieving hand tension and stress, paving the way for today's stress balls and therapy putties. From failed wartime experiment to quirky household hero, Silly Putty reminds us that not every invention has to be serious to make a serious impact. Sometimes what seems like a laboratory mistake turns out to be the most satisfying thing to squeeze, stretch, and smush. Segment 4. The Kite, a Tale of Wind and Discovery. Long before satellites orbited the Earth or drones buzzed overhead, we had kites. Simple? But centuries ago in ancient China, they were more than just colorful distractions in the sky. They danced at festivals, carried messages between towers, and were even believed to ward off evil spirits. But as history would show, what began as play would rise to far greater heights. In the 1700s, a curious American named Benjamin Franklin tied a key to his kite string and flew it into a thunderstorm, not to make headlines, but to understand lightning. With one risky experiment, he helped unlock the secrets of electricity and inspired generations of scientific explorers. By World War I, the kite had evolved again, used by military scouts to lift cameras high above the battlefield, capturing images before airplanes took to the skies. Later, meteorologists launched massive box kites equipped with instruments into the upper atmosphere, gathering wind and pressure data, long before we had balloons, satellites, or digital forecasts. All from paper, wind, and a bit of string. Kites taught us that curiosity doesn't always start with a laboratory. Sometimes, it begins in a field, with a breeze, and a child watching the sky. From folklore to physics, from fun to forecasting, the kite reminds us that some of the simplest inventions can carry the heaviest questions. Segment 5. Lego, bricks that built more than castles. In 1958, in a quiet Danish workshop, a carpenter named Ole Kirk Christensen and his son Godfred weren't thinking about engineering degrees or space stations. They were thinking about play. They designed a plastic brick that clicked just right, with clutch power so perfect, it felt like magic in your fingers. They called it Lego, from the Danish leg godt, meaning play well. At first, these blocks built toy houses, fire stations, and rockets in the minds of children. But something unusual happened. Engineers began to notice. So did educators, therapists, scientists, architects, even astronauts. Robotics programs started using Lego to teach kids about sensors, logic, and design through Lego Mindstorms. Therapists used Lego models to help children express complex feelings without saying a word. Architects built city mock-ups with bricks before moving to CD software. And at NASA, scientists used Lego models in gravity-free simulations to test movement and structure in orbit. Not bad for something once tossed into a toy box. And maybe that's the secret. Lego was never just a toy. It was, and still is, a system for turning imagination into structure. A tool that speaks to minds both young and brilliant. An invitation to build a world, one click at a time. Because when you snap two bricks together, you're not just building something small. You're building what could be. An intro to episode 6. So what do a coiled spring, a blob of goo, and a box of bricks have in common? They look like toys. They feel like toys. But they are inventions in disguise, quiet revolutions hiding in plain sight. They prove that imagination isn't just for children. It's for anyone bold enough to ask, what if? Because when we play, we test boundaries. We question rules. We build worlds that don't exist yet. That silly spring? It inspired antenna technology and space experiments. That gooey putty? A stress reliever, a keyboard cleaner, born from a wartime failure. Those humble Lego bricks? Now part of robotics labs, therapy rooms, even zero-gravity tests in orbit. Imagination is not just child's play. It's a launch pad, a lab, a revolution waiting to happen. And toys? They remind us that invention doesn't always wear a lab coat. Sometimes it wears overalls or pajamas. Sometimes it starts with giggles and ends with genius. So as you look around your room tonight, at the old toy box, the plastic bricks, the spinning top collecting dust, remember, inside each of them lives a spark, because the future might just be hiding in your toy box. Eyes next time on Everyday Inventions. We explore a different kind of discovery, one not born from play, but from error, from mistakes that changed everything, and in some cases, saved lives. From penicillin to pacemakers, we'll uncover how accidents led to breakthroughs. So hit that like button, subscribe, and join us next time as we dive into accidents that saved lives.